Hey everyone. So in the previous video, we began organic chemistry in A-level content and we talked about how A-level organic chemistry is divided into the aromatic compounds and the aliphatic ones. Aromatic were like an A2 syllabus and then aliphatic had saturated or unsaturated, including alkanes, alkenes and alkynes. We talked about formula writing. We knew there were four kinds of different chemical formula: displayed, structural, condensed, and skeletal. Last time we did not talk about skeletal ones, and probably we will start them right now. But let's recall that displayed had all the atoms and all the bonds represented very clearly. You could not skip even a single bond. In structural, you had the liberty of writing the hydrogens together with the carbon without bonds. And in condensed, it was preferable that all the branches were written in brackets. We did some examples last time, and today I am bringing some questions from past papers to help you understand how the condensed formula are written and how you should be able to figure out their actual structural formula. We don't have to go into the question details, but we should be able to look into the structures. Like let's see the structures of all the options in this particular question. Option A is a CH3, so CH3 we know that. Then there's a CH, so C and then H. Since there's a bracket that is having the OH in it, which means OH is a branch. And then you can see another CH2, so CH2 towards the right side, and there is CH3. So option A is this structure. Let's look at the structure of option B. Starting from the left, you can see a CH3, then there's a CH2, then there's another CH2, one more CH2, and then OH. OH is not written in a bracket because in the corner, obviously it's written in the corner, which means it's on the terminal cornered carbon. Terminal means the carbon on the corner. Option C, you can see there is a 3 outside the bracket of CH3. It means there are 3 CH3 groups attached to the same carbon. The carbon which I am encircling right now has 3 CH3s. So CH3 on top, CH3 on left, CH3 on bottom are attached to the same carbon. And there's OH on the right side, so this is the OH on the right side. This is the structure of option C. 3 CH3 groups on the same carbon and then OH. Option D has 2 CH3 groups. You can see there's a bracket and there's a 2 outside it. So there are 2 CH3s, one on left and one on top, attached to the same carbon. Then you can see that outside the bracket the CH is there. So the carbon has 2 branches of CH3s. There is CH, like means, which is 1H. Then there's a CH2 here, so a CH2 group, and then OH. So you can see that option D has technically one branch, but since the other one is also on the corner, we count both as branches. While option C has 3 different methyl groups. By the way, CH3s are called methyl groups, so CH3 groups on the same carbon. This is how the structures are written. Let's go for another question and let's explore more on that. In this particular question, let's try to write the structural formula from left to right. You can see there's a CH3, so CH3, okay. Then you can see there's a C with O. Now remember, you might think that there is alcoholic group OH, but they did not write OH in a bracket, which means it's only one oxygen. And do you know how many bonds each oxygen makes? If it's just oxygen, it makes 2 bonds. So there are 2 bonds with the oxygen. Then there's another carbon after the oxygen, so one more C with H2. Then you can see there's one more CH2, and then there's OH around it. So you should be able to notice that if it is an oxygen without the hydrogen in the middle, it is actually a double bonded oxygen, and such structures are called carbonyl. This is a carbonyl group where oxygen and carbon are attached through a double bond. Let's go for option B. Option B has a CH3 on the left side, so okay. Then there's a CH2. Then you can see a CH. Now it is an alcoholic group in the bracket, so bracket represents a branch. So OH is there, and then you can see CHO. Do not be confused by HO thinking it's OH. HO is not equal to OH. But you might think they are the same, they are literally the same. See, if the carbon has HO, if the hydrogen is closer to the carbon, we will talk more about it by the way, but if you see CHO, you should notice that it is H with the carbon and oxygen has a double bond with the carbon, because otherwise the valency would not be complete. But do not worry about it, we'll do more on that in the coming structures video. Let's go for option C. You can see there's a CH3 on the left side, so okay, there's a CH3 on the left. There is CO, remember, an oxygen without hydrogen is double bonded oxygen. So this is here. Then you can see another CH, so I'm writing CH. There's OH in a bracket, so OH is a branch, and there's a CH3. This is option C. Let me highlight these structures so that we are all on the same page and it's not confusing for us. And now let's go for option D. Remember, there are two CH3s on the same carbon. The carbon that I'm encircling right now has two CH3s, one on the left and one on top. It doesn't matter which direction you're drawing it from, but you should know it, like left and top are more easier ways of telling you guys. Then you can see there's a OH in a bracket, so it means OH is a branch. And then you can see there's CHO. Remember, CHO means CH and double bonded oxygen. Double bond should be on the carbon, obviously not the hydrogen. Hydrogens can't do double bonding. So this is the structure D. This is how the structures are in the exam, and I'm just trying to help you understand how you should be able to deconstruct these structures in your mind. Let's go for this question. It has multiple structures. I'm picking structure G. You can see structure G starts with a CH3, so there's a CH3 here. Then there is CH2 two times. So CH2 two times means CH2 and CH2. It's not a branch, because if it was a branch, it would be written around a CH. A CH2 in a bracket means multiple CH2s. So there are two CH2s over here, so I opened them. And you can see there's a CH3 on the right side, so CH3 on the right side. This is how the structure has been opened up. It is a 4-carbon structure. Let's do a similar thing with structure H. You can see there's a CH3 and 3 outside the bracket. So on the corner there are 3 CH3 groups, top, left and bottom, attached to the same carbon, the carbon that I'm putting in the circle right now, or rather I should say the oval. What is attached to this carbon on the right? It's a CH2 group. Now what is attached? Another CH. And there's CH3 twice, so it means one CH3 on top and one CH3 at the bottom, or any direction, any random direction. So I want you to take one more moment, take one more second and figure it out. See, on the left sorry for this fluctuation, on the left there were 3 different CH3s. So 1, 2 and 3 attached to the carbon that I'm putting a tick on. Then you can see there's a CH2, so CH2, there's a CH, there's a CH, and there's a 2 outside the bracket. So this one and this one. This is the structural formula of H. I don't think we need anything for J, because J is pretty simple. It's like structural, but it's very clear right now. Let's go for this question and let's see which structures are here. Option A starts with CH3 twice. You know what it means? It means there are two CH3s attached on the same carbon which is outside the bracket. So CH3 on top, CH3 on left, attached to the same carbon. The carbon that I'm putting a tick on is here, which is attached to two CH3s. It has H over here. There's another CO2. Now, we will talk about it in a whole different video, but CO2 means that this is a carbon attached with a double bond and one more oxygen. This is ester group. In organic chemistry, CO2 in the middle of a structure is equals to ester group. If you are not sure about the ester group, I would really recommend you watching my video on esters. Now outside the CO2 there's another CH2 and there's another CH2 and then there is a CH3. This group over here is known as the ester group. Let's pick more structure. Let's go for structure B. It starts with a CH3. Then you can see there are CH2 twice. This means continuation of CH2s. One CH2, then one more CH2. Then you can see there's a CO2. Remember what CO2 means? It means ester group. Then you can see there's a CH. And what else? There's a CH3 twice in the corner. CH3 twice means a branched. So like this. One on top, one on right. Both these CH3s are in the bracket. Let's go for structure C. It starts with a CH3. So there's a CH3 over here. Then CH2 twice. CH2 in a bracket does not mean branch. CH2 means two CH2s in a continuation. Then there's a CO2 which means ester group. Then there's one more CH2, one more CH2 and then CH3. Because there's a two outside the bracket of CH2, that is why these are two over here. There's a two over here, these are the ones. Let me put this in a different color for you to understand this. CH2 with a double means two different CH2s. Let's go for structure D. It starts with CH3 twice, which means one on top, one on left, and both attached to the same carbon, which is this one. CH. CH. I also wrote CH here. Then what do you see? You see a CO2. CO2 means ester group. Then what do you see? You see CH. So CH. And then there's a CH3 with a 2 outside it. So CH3, CH3. These CH3s are the ones which were inside the bracket. This is the ester group. The CO2 is the ester group. So I hope you are able to figure out how the structural formula are related to the condensed formula. In today's video, exactly what we're going to do is we're going to talk about the skeletal formula. We're going to talk about the skeletal formula. Now, skeletal formula is really unique in a way that you do not show any carbon of the main alkane chain. So each carbon becomes a dot. Each carbon becomes a dot, literally a dot. And each bond is equals to a line. Let me show you how. In C with 3 hydrogens attached to one more carbon, I'm drawing basically a propane right now. So if I wanted to draw a propane, you can see there are 3 carbons. Carbon 1, 2, 3. And you can see there are basically 2 bonds between like 3 carbons. You put 3 dots and then you connect them. I did not connect them really like neatly. This is how I would connect them. Literally, this is propane. This is the structure of propane. This is carbon number 1. This is carbon 2. This corner is carbon 3. Let's pick one more. Let's say I am drawing a branched structure. This is the displayed formula right now. But in the coming videos I'll be using structural formula because I'll be assuming you already know how it's made, right? Okay. So this is the displayed formula of a branched structure with bromo functional group. Carbon 1, 2, 3, 4. So how many dots? 1, 2, 3, 4. Connected by 3 bonds. This is carbon 1, 2, 3, 4. 1, 2, 3, 4. You can see on carbon number 3 there's a branch coming out, but it's only one carbon branch. So what do? We just draw a single line coming out. This here represents a carbon, so we don't show that. Do we have something on carbon number 2? Yes, we have a bromo group. So for bromo it's not a dot. For bromo you draw a line and you write Br. So if it's ending without a symbol, it's a carbon. If it's ending with a symbol, it's a functional group or any halogen. This is how you wrote that. Let's pick one more structure. Let's go for a more complicated one. CH3, CH3, H, C. Then let's say maybe bromo group. Then maybe CH. Let's pick OH over here. Let's pick another CH3 over here. Let's pick another CH3 over here. I know it's a more complicated structure, but bear with me, we'll do that. 1 carbon, 2, 3, 4, 5. This is the longest chain. This is the continuation. Let's say this is the continuation. I'm numbering them. 1, 2, 3, 4, 5. There are 5 carbons. Bromo is a functional group, is like a non-carbon atom. OH is a unique functional group, and these CH3s are branches. These are branches. So let's call them branch. Now, how many carbons are in a continuation? So there are 5 carbons. So 1, 2, 3, 4, 5. These are connected like in a line. So we have 5 carbons connected through 4 bonds. Number them: carbon 1, 2, carbon 3, carbon 4, carbon 5. Do we have something on carbon 2? Yes sir, we have OH group. So OH group is written like this. Make sure in structural formula the OH is written this way. Even in skeletal formula you show the hydrogen of the functional group. It's not like, okay, it's the skeletal formula, why are we drawing the hydrogen? Don't write the oxygen only. If it's a hydrogen of the functional group, you got to write that, because it's not an ordinary hydrogen, it belongs to the functional group of OH. So do show that. What do we have on carbon 3? So on carbon 3 we have a bromo coming from one side and a 1 carbon branch. So bromo is written with a line and the symbol. But for a branch, you just draw a line and end it blindly. You don't do something in the ending of the line. It's just ended very abruptly. And the ending of the line like this means a carbon. You don't have to write a symbol over here. You don't write C. But for Br, you write Br. What do we have on carbon 4? Sir, on carbon 4 we have another branch. So draw it like this. It ends blindly. So this is your branch. This is your branch, this is your bromo, this is your OH. This is how it's given. Skeletal formula written like these. Let's pick one more and then we'll end it. Imagine if you have a structure like this. I'm making a complicated structure, but this is for our practice. Now let's figure out how many carbons are there in the continuation. Let's start numbering from the perhaps right side. Okay, if you count this as a carbon, remember it is not a carbon. It ends with a symbol of Cl. So Cl means chloro. So this is not a carbon. Carbon is this one, the one without a symbol. 1, 2, 3, 4, 5, 6, and then 7. Sir, but what is this? It's a branch. It's a two carbon branch because it has two corners. One corner is this one turn is this, and the ending blindly or the abrupt ending is also a carbon. So it's a two carbon branch. What about this? It's also ending blindly. It's also one carbon branch. What about this? It's an OH group. What about this? It's a bromo group. So how many carbons? 7. It means one carbon, 2, 3, 4, 5, 6, and 7. On first carbon you have a chloro group, so this is a chloro here. On second carbon, let me number it: 1, 2, 3, 4, 5, 6, 7. On second carbon you have OH group. You can write it from any side, no issues. On third carbon you have a single carbon branch, but a carbon is never around, so it's CH3. On carbon 4 you have a two carbon branch like this. So corner is CH3, middle is CH2. Then on fifth carbon you have a bromo group coming out. What about the rest of the carbons and stuff? You can put in the hydrogens later. Like here you will have two hydrogens because of the bonding. On carbon 2 you will have only one hydrogen. On carbon 3 only one hydrogen. On carbon 4 one hydrogen. On carbon 5 one hydrogen. Carbon 6 is double hydrogen, and carbon 7 is 3 hydrogens. Sir, how do you know how many hydrogens? By counting the number of bonds, but gradually you will get a practice of it. So you can see in the longest chain, I should not add chloro in the longest chain. It starts from here. My chloro is a functional group, chloro is a functional group. You have a branch here on carbon 3, you have a branch on carbon 4, which is a 2 carbon branch. You can see that you have a bromo on carbon 5 and a chloro on carbon 1 and OH on carbon 2. So this is how you should be able to figure out the skeletal and structural formula. I hope it's clear to you, and the coming video will pick structures from past paper to solve more of these. Stay tuned guys. Thanks.